Hello everyone, welcome to this Men&Mice webinar. My name is Peter Peterson, and today's webinar is focused on fighting abuse, how to fight abuse with DNS. This is where Carsten Strotmann touches up on the subject, explains in details what this is all about. And Carsten, you were actually going to play an interview with Sommer on the subject, I believe.
Yes, I recorded an interview with Mr. Uwe Sommer, who is an expert on the field of mail and especially fighting abuse in mail systems. Unfortunately, we just encountered technical difficulties just now playing the video with audio signal. So we can play the video, but not the audio signal. And for an interview, it's kind of useless to just see the video. So we will play the interview at a later time, and we will inform everyone over Twitter and over our webpage when that will be. Today I will cover the parts about the underlying technologies, SPF, DKIM, and DMARC, which were also planned for this interview.
Okay, so everyone, please note that you are on mute, but you can submit your questions through the GoToMeeting control panel, and that we will upload this webinar to our website within few days, and we will either compile that video into the webinar at that time, or we have a separate session where we play it with questions and answers available at that time as well. So, having said that, Carsten, the audience is yours.
Thank you, Peter. Hello, everybody. So today I would like to speak about SPF, DKIM, and DMARC, which are technologies being used in the mail field to fight abuse in mail systems. And all these three technologies are based on DNS. That makes it the connection to Men&Mice, because we in Men&Mice we are the DNS experts, not so much the mail experts, but because all these technologies are built on DNS, a DNS administrator needs to know about this, how they work, and what is meant if the mail administrator comes and asks for putting in a DKIM or SPF record. So here we go. First, we talk about SPF, which is the Sender Policy Framework, which is the oldest of the three technologies we talk about today. And SPF defines the addresses and net blocks where sending mail can be originated for a given domain. So we will have in a few slides a graphical view how SPF works in mail reputation systems. The information on the SPF is inside the TXT record, so it's a traditional, just normal TXT record that everybody can put into their own DNS zone. There was from a certain time there was a dedicated SPF record, but that has been deprecated by the IETF because it was largely ignored by the mail and DNS administrators. So when SPF was first developed, that was some 16 years ago, the TXT record was easily available, and so the developers of SPF, they used the TXT record. And in the early deployment, everyone also just put in the TXT record, and later on the IETF standardized the SPF record because it has some benefits to have a dedicated record type and not overloading the TXT record. Unfortunately, it was impossible to motivate all the mail and DNS administrators to move from TXT to SPF record type. So after some time, after like 8 years of unsuccessfully promoting the SPF record, the IETF decided that SPF has to die because the vendors of DNS software, they don't want to maintain a record type in their software that isn't really used. If you want to dive deeper into SPF, especially into the format of the SPF record, there's a very good website, www.openspf.org, that explains the whole standard and the way how SPF content in the record is being created. So here is an example. I have the SPF record for the google.com domain, and that gets being used if someone receives an email that is supposedly coming from someone at Google. So the SPF protocol format allows to split up the SPF information across multiple resource records, and that is highly, highly recommended. So if you use SPF yourself, don't put everything into one record, because that record can be big, and if it is too big, it can be either create network problems with fragmentation, for example, or it can force DNS to use TCP all the time, which has some other negative implications, or even it can be used in denial of service attacks, in amplification attacks. So best is to split the SPF data into multiple records, like it is done here for Google. So this is the real Google data that you can find on the internet. It's a TXT record, and the first field in the TXT record is the version equals SPF1, that's the version number, and SPF version 1 is the first version of SPF that we have. And then all that we have in this record, which I call the base record, is an include statement that tells the receiving mail server that there is more information at a domain name called _spf.google.com, and that all the information provided here should be used for soft fail. Soft fail meaning if the validation or checking of the SPF information does fail, meaning that the email is coming from an IP address that is not within the Google SPF range, receiving mail servers should not just throw away the email immediately, but should make an informed decision based on their either local policy or on the DMARC policy, which we will talk later about DMARC. But first here we have an include, and a mail server that is receiving mail from Google would now, after seeing this SPF record, ask for a TXT record in _spf.google.com, and this is how that one looks like. This is the second record. It's on a different domain name, _spf, and this one can be a little bit larger in case of Google, because Google is a large company and possibly multiple departments into Google are maintaining different network blocks. They include here 3 other domain names for the SPF information. So even at the second level, we don't have the final information. We have just another level of indirection here. We include _netblocks.google.com and netblocks2 and netblocks3.google.com. And again, we soft fail for all the information here. And then if we ask for the _netblocks.google.com TXT record, then we find the meat. We find all the IP address blocks that are defined for Google. These are the IPv4 address blocks in the first include. The other includes might also include IPv4 or even more includes, or IPv6 addresses, or other kind of data. So for example, in SPF you can also specify not only IP address blocks, you can also specify domain names, which will be then looked up in the DNS for their respective IP addresses, or you can just specify, for example, all the MX records for a given domain are allowed to send. So the validating side, the receiving side, would then look up the MX record, would look up the address records for the MX record, and then use that email, that IP addresses for checking the incoming email. If you split up your SPF record like it is done here at Google, make sure that every SPF TXT record is below 1200 byte in size. That's the magic number, basically, because you want to be under the fragmentation threshold for IPv6, which is something around 1232 bytes. So be careful not to make your SPF records too large by putting everything in one record type. SPF allows these includes, and you should use them. So how does SPF really work in the network? Here we have an outgoing mail server on the lower left side, sending an email to a receiving mail server on the right side, and it's sending on port 25 from its own IP address, which is 192.0.2.123. The receiving mail server now only sees the IP address first and the port number from the outgoing sending mail server, and it doesn't know if that is a legitimate server for the example.com domain. So the receiving mail server accepts the connection and asks for the headers. So the outgoing mail server sends the hello command, sending its own domain, and then it also sends the from line, the header line, saying from which email address this email is coming from. And once the from line is being sent, the receiving mail server will look up the SPF record for that domain part in the from email address. And the SPF record coming back contains the IP address blocks that are allowed to send email in the name of example.com in this case here. And we see this TXT record, this SPF record, contains the whole net block 192.0.2/24. And the minus all here means hard failure. Unlike with Google, which had a soft failure, this one is a hard failure. If an email is sent from a server that is not within that IP address range, the receiving mail server should just block the email and not take it into processing. But here everything is good, and the data is being checked, and everything is good, and the mail has been received. Now, SPF was the first of these technologies to help fighting abuse with mail, but it's problematic with some mail functions, especially where mail is being sent indirectly. That happens with mail forwarding. So if a user happens to have a mail account at some server, but is not actively using that server anymore, but has put in a so-called a forwarding statement, something that, for example, customers of Yahoo are doing lately, then mail is just being forwarded by that server, and the forwarding server is being seen as the sending server at the receiving side, and that doesn't match the originating mail. And when only SPF is being checked, that can be then just blocked. Same problem is with mailing lists, because mailing lists also take emails and distribute them to other people and sending from their own IP address. And sometimes it's about web forms. And there was a blog post, a very enlightening blog post by Peter Hanstein from Norway. It's called "Is SPF Simply Too Hard for Application Developers?" And I recommend you to look into that. We will have the link later in the show notes. It explains quite interestingly what can go wrong if application developers don't know about SPF and implement web forms wrongly. So here we have an example what can go wrong. Here the outgoing mail server sends to a mailing list server. That mailing list server does SPF checking and everything is good in this case, but then the mailing list server itself distributes the email, which is originally coming from user at example, but it's now coming from the mailing list server, and the mailing list server uses the IP address 203.0.113.23, and the receiving mail server now wants to check SPF, looks up the SPF record for example.com, gets back that record, and that record contains just the net block 192.0.2.0/24, where the IP address of the mailing list server is not within. So from the view of the receiving mail server, this looks quite like a spoofed email, maybe spam, maybe malware, so it will block that attempt of sending email because it's not coming from the right IP address. While with the mailing list, this is quite normal, and if mail administrators implement and DNS administrators implement SPF, it can happen that then the users in that domain have all of a sudden failures sending mails via mailing list servers. That has to be taken into account when implementing SPF. There is a solution after SPF has been developed and its shortcomings were apparent. Another group of administrators and researchers came together in the ITF, and they worked on domain keys identified mail, or DKIM. And DKIM works differently. DKIM doesn't give the IP addresses or net blocks. Instead, it signs part of the email header with a private key, and it publishes the public key that matches the private key in DNS. So the DKIM is being used to validate selected mail headers and also the mail content to make sure that the headers and the content are coming from the correct sending site. And it's not that the transport path here is secured, but it's just the origin is secured. We don't care which path an email is going. It can go over one hub, it can go over multiple hubs, we don't care. And as long as the email isn't changed in transit and also the headers are not changed. Of course, there are some headers that are changing on every mail hop, so DKIM only signs selected headers, not all of them. It only signs the headers that are not being changed on relay machines, and it signs these headers that are very important to identify the sender of the mail. The good part is that there's no upgrade of the user client, that is your Outlook, Thunderbird, or Kmail or something that you use that's needed. However, it is possible that email clients do per user signing, but usually DKIM is being used per domain, that is per company signing or organization signing. Also, the developers of DKIM developed this in a way that the management of the DKIM signing can be outsourced. So if you use a mail provider like Men&Mice is using Microsoft Office 365 for its mail service, then the outsourcing provider can take care of DKIM, which is the case in Men&Mice. And there's no extra public key infrastructure needed. It all depends on the DNS. Here are some resources. There's the dkim.org website and the relevant RFCs for you to research and read later. So here we look at the DKIM signature. This is the part of DKIM that is in the mail that is being sent. So every mail gets an extra signature that is being inserted in the header of the email. And here we see it's for DKIM version 1, and there is currently only version 1. The signatures are created with RSA keys and SHA-256 hashes. Then we have the the canonicalization algorithm. Two options here, either relaxed or simple. And simple means that the headers shouldn't or cannot be changed, or cannot have new headers added to the process while sending through the internet. And relaxed means only the listed headers here are being really checked. So usually today most companies use the relaxed algorithm for the canonicalization. Then we have the domain, which is the domain of the sending party, which is Men&Mice on Microsoft.com in our case. And this is where the public key is found that is being used to verify the signature. And then we have a selector, and the selector is a domain name, a subdomain of the domain name that is being used to select a specified key. This is interesting because this can be used then to create seamless key rollovers. You can change your keys. You have key number 1 on selector number 1 and key number 2 on selector number 2. You can prepare all your DNS beforehand, and then at one point of time you switch the key on your mail server, and the previous mail has been signed by the previous key, and the new mail will be signed by the new key. So that allows for seamless rollovers of the key information. Then, how is the selector and the domain being used? The DKIM public key is found at the TXT record at a domain name. The domain name is built from the selector. Then the subdomain _ domain key is being added on the right, and then the base mail domain, what's in the D field, it's also being added. So for Men&Mice, it is selector1-men&mice-com _ domain key .menocmus.onmicrosoft.com. And if you dig for a TXT record on that name, you will find the public key. We also have a version number here, DKIM version 1, key equals RSA, means that is an RSA key, and P equals, that is the key materials, that is the public key, hence P equals. Then back to the DKIM header, we have the list of the headers, which is in our case from date, subject, message ID, content type, and MIME version. These headers are being signed. All the other headers that might appear in the email are not signed, especially the received from headers that will be inserted by every hop on the way. Then we have the body hash, and that is a hash of the whole body of the message that is being used to make sure that nobody on the way is tampering with the content of the body. So to be clear, a DKIM does not encrypt any data. So all the email data is still sent in the public. Everyone can read. But with this, it's not possible to change the data on the transit way. So the intermediate mail servers cannot change the message body nor the headers that are being signed. And then the last field, that is the signature. It's a binary blob and it's encoded in base 64 so that it can be sent with 7-bit ASCII over the internet. Now, how does DKIM work? While sending an email, the outgoing mail server holds the private key and it signs the outgoing mail, the headers of the outgoing mail, and it computes the hash of the body, signs both, and adds the DKIM header into the mail. Now here in this example, we work with a mail forwarder, something that would break with SPF. Sending mail from user at example goes from 192.0.2.123 to the mail forwarder. The mail forwarder adds its own headers and then forwards the mail from its own IP address to the receiving mail server. The receiving mail server looks up the DKIM public key based on the information in the DKIM header. So it builds the domain name, asks for a TXT record at that domain name, gets back the public key, then encrypts the signature, and then the signature is actually the hash of the body and the headers, checks if the hash computes to the same value, and if it does, we are sure that the email came from the right place, which is the sender it supposedly is being sent from, and it has not been changed on the way. So DKIM gives us two promises here. We know it's coming from the right sender, and we know it has not been changed. And because we know it's coming from the right sender, we can find a lot of spam email that is sent with spoofed mail addresses. If we know that an email domain has DKIM and an incoming email is not signed at all or is signed with the wrong signature, we can just block that email. However, after SPF and DKIM has been deployed, mail administrator wanted to have more control over what the remote side, the receiving side, is doing with this information. And both in SPF and with DKIM, there was no way to define a policy, meaning what should happen to an email where either SPF or DKIM doesn't match the data found in DNS. And that then became DMARC, the solution to this problem. DMARC stands for Domain-Based Method Authentication, Reporting, and Conformance, and builds on top of SPF and DKIM, basically enhances both with a policy, and it allows the owner of an email domain to publish a policy what should happen if either SPF or DKIM or both are failing. And it also creates a feedback channel where the receiving side can let the domain owners know of spoofed mail from his domain. And also the DMARC policy, same as SPF and DKIM, are stored in DNS. So DMARC is also stored as a TXT record. And here we look only at the data part of that TXT record. So first we have a protocol version. It's a DMARC version 1. You see the format of these TXT records are very similar to DKIM. Then we have the policy, what should happen if either SPF or DKIM fails. So we can reject, we can say that it should be a soft fail, and there are other policies possible. You can also specify the percentage of messages that should be checked. Here percentage is 100%, so every email needs to be checked, needs to have the SPF and DKIM checks on them, or either of both. It's possible to lower the percentage, so it's then less load on the receiving mail server. This is especially important if a company is sending out mass mailings, which are properly signed, but can create a lot of work on the receiving side, especially if like a company is mailing out some information, maybe on a webinar, to some million customers out there, and half of the million customers are at Google Mail. That would be a lot of work for Google Mail, checking all these signatures. So this can be lowered on the receiving side in the policy, saying, oh, it's okay to just check 20% or 25% of the emails. And this is the important bit of the feedback channel. This defines an email address where the aggregated misuse reports should be sent. So this is a mail email address, a mailbox on the receiving side, and if on the sending side, and if a receiving mail server finds an email that has been spoofed, either SPF spoofed or DKIM spoofed, it will then collect all the misuses for, let's say, 24 hours, and then sends an aggregated report, which is an email with an XML attachment to that email address. And there are systems that can receive these email addresses, read the XML, and create proper reports from them. So if you implement DMARC, quite possible that you get a number of these reports per day. And while it's nothing that you want to look manually at, because it's just XML and it's quite hard to read for humans, but there are some tools that you can use to automate this and read the XML and create reports for you. So this is what I have on SPF and DKIM and DMARC. So at this point we would play the interview, but as I said before, and maybe for the people who joined later on, we have technical difficulties playing the audio part of the interview, and we will play that interview a little bit at a later time, not today, but we will announce that. Sorry for that. But do we have any questions on what we have talked here about on SPF, DKIM, and DMARC?
Carsten, thank you for this presentation. So regarding questions, I don't see any questions right now, but you can submit your questions through the GoToMeeting control panel you have there. So Carsten,
so one question, yeah.
Yes. No, keep
One
going.
question that I hear from customers from time to time is how to enter all this information into DNS, and it's normal TXT records. So if you manage your DNS with like the Men&Mice suite, you can put all the data into quotes like it is shown here and put that in. If you manage your DNS zones by a text editor, basically you do it the same, but also it's important to put the data in quotes. And because if you don't put it in quotes, you have to escape the semicolons in there. Because the semicolons have special meanings in the DNS. They are a command, and while the DNS server will not object, it will not give a warning or anything. But if, for example, this DMARC record here, if you put it without the quotes in the DNS, the zone loads just perfectly, but it would just read the version equals DMARC 1, and then semicolon would be start of a command in the zone file, and everything after the first semicolon will be just not seen by the DNS server. So be careful to put the data into the double quotes. And also, if you have long data that you put into TXT records, like SPF can be quite long, and if you, for whatever reason, you don't want to split up into multiple SPFs, every TXT record can have 255 characters in there, but the TXT record itself can have up to 64 kilobytes of data. So what you can do is you write the first part of SPF into the first 255 characters with quotes, and then you do a closing quote, space, and start a new quote, and put another 255, quote, space, another 255, and so on and so on. And you can put up to 64 kilobytes into one TXT record. Not that I recommend that, because it makes very large DNS responses, which are bad for multiple reasons. But if you want to do that, that's the way to do it.
Okay, Carsten, I have a question here from Florian. Can you give a short overview of given common mail servers with support for DMARC or DKIM nowadays? You already mentioned Gmail, for example.
Yes, all the big ones like Yahoo Mail and Microsoft and Google Mail, and in Germany I know GMX and Web.de and Strato, they use DKIM. And it's not so much used in organizations and smaller companies, which is one of the reasons why I'm doing this webinar here, also to spread the word that this technology is out there, is proven, tools exist. In case of mail server support in looking at products, usually you the DKIM functionality is not built in the mail server itself, but it's a separate product. For Unix-based operating systems, there is Open DKIM, which is an open source solution that works with like Postfix or SendMail or XM. That can be used to add the DKIM signatures. Then there is Open SMTP-D from the OpenBSD project that, if I remember correctly, has DKIM support built in, so it can sign automatically if you give it a private key. And for SPF nowadays is mostly part of anti-spam software, so it's in Spam Assassin and RSpamD, and also commercial products that do anti-spam checkings.
Very good. Carsten, just a quick question from another attendee here. Can you explain again why the SPF DNS record type was not successful?
Yeah, when SPF was first designed, the developers of SPF, they used the TXT record because that was already available and good enough for their needs. And the problem here is we now have multiple multiple protocols that use the TXT record. Let me show you an example here. Here on my screen, if I ask for the TXT record of Microsoft.com, we have here the SPF record, which is one of the record. Then there is another TXT record on the same domain called a DocuSign for, not sure for what protocol or product that is. And there's another one which has no indication on the protocol whatsoever, which looks like also a base 64 encoded binary blob. Now, if software that wants to check DKIM, that software is asking for the TXT record of Microsoft.com or any other domain, and it gets all these three records back. And it needs to be able to distinguish a proper SPF from all the other stuff that might be on the same record type. And that could be problematic. We know application developers, they are maybe not testing with all the stuff that can go wrong. They just test the positive path. So they test just with one SPF TXT record and it works, and they ship the software. And then if some other TXT record appears on the same name with some random content, the software just crashes. Because of that, the ITF started with having their own record type called SPF. And let me check if Microsoft maybe uses that SPF. So it's record type SPF. And no, there's no SPF record type at Microsoft.com. And even though the ITF has standardized on the SPF record type and the RFC was out there and it was supported by bind on all the name servers, the message never really got through to the mail administrators and DNS administrators. So nobody was using that. Some people did research and did statistics on the use of SPF versus TXT record for SPF record content type, and SPF record usage was below 1% worldwide, and it didn't really change in the 8 years or so where SPF was available. So then there was pressure on the ITF from the vendors to deprecate SPF, the record type, because vendors don't want to just maintain a dead horse. Because everyone was still using TXT anyway, it was then considered, okay, we cannot force the world to switch, so we have to live with this imperfect solution of using the TXT record, and that is what is being done today.
Very good. So, Carsten, would it be fair to say that in a perfect world somewhere in the future where everyone has implemented DNSSEC, we can use different methods for securing all of this stuff?
Yeah, DKIM, for example, is much more superior than SPF. And it doesn't really make too much sense to implement both DKIM and SPF. So, but SPF is the easier one because it's just text, and you put in the IP addresses, you collect the IP addresses of your organization, put that in a text bracket, and it's done. It can be maybe done in half a day or so, and it's ready. Implementing DKIM is a little bit more difficult because you have to implement the DKIM signer. You have to install something on your mail infrastructure that signs stuff. So it would be better if SPF would be phased out, DKIM would be used everywhere, and then of course we want to trust the DKIM information. We want to be able to trust the public key that we receive from DNS. Hence we need DNSSEC really to be able to trust DKIM and DMARC. And then it would be a much better world than it is today. And maybe we would have less spam, but that is another story.
Well, until then, this is quite useful, Carsten. So I don't see any further questions. So we will save this recording to our website and possibly add the video streaming, the interview as well, or we send a separate post on that item. So Carsten, thank you.
Peter, wait, there's another question.
Oops, right you are.
Just came in.
So the question here is from Jeffrey. If a spammer spoof an email from your domain, how does the receiving email server know you have a DKIM setup?
It can either look for no, it cannot know it because it doesn't know the selector, so it cannot just ask the DNS because the selector in the domain isn't known, but it could store the DKIM information from previous genuine mails that it has received. So, for example, if it has received an email which was DKIM signed, and it looks up the DKIM public key, and then there is a time to live on that public key. So it is able to store that public key for that amount of time that is in the TTL, and for that amount of time, it's the TTL is the intent of the administrator that DKIM is in use. So it could use that cached information for that amount of time.
Very good. Thank you, Carsten. So I don't think we have any further questions. So Carsten, shall we put an end to this webinar now?
Yep. Thanks everyone for listening, and we will post information on the upcoming webinars, or we already have done that on our website. The next one is about DNS and DNSSEC monitoring. We give 15 essential monitoring tips, what you should monitor in your DNS and DNSSEC infrastructure.
Excellent, Carsten. Thank you very much for today's webinar, and thank you all for attending, and have a nice day.
Thank you. Bye for now.